Hello friends, today we will discuss about buffer solution. First of all, we give the definition of buffer solution. The solution whose pH remain unchanged by adding small amount of acid or base to it is called buffer solution. Actually, the word buffer means resist. It resists the change of pH of a solution. Buffer solution is made by mixing weak acid with its salt. As for example, acetic acid is a weak acid and its salt is sodium acetate. Another type of buffer solution is prepared by mixing weak base and its salt. Example, ammonium hydroxide, weak base and its salt is ammonium chloride. Now, the mixture of weak acid and its salt is called acidic buffer, and the mixture of weak base and its salt is called basic buffer solution. The pH of buffer solution is determined by an important equation called Henderson equation. For acidic buffer, the pH of buffer solution is pKa plus log of salt by acid. And for basic buffer solution, POH is equal to pKb plus log of salt concentration divided by base concentration. Now, let us discuss about the mechanism of buffering action. Acetic acid and sodium acetate, which represent a buffer solution. Acetic acid dissociates as acetate ion and H plus ion. Its salt, sodium acetate, dissociates as acetate ion and sodium ion. Now, if you add small amount of acid from outside, then concentration of H plus will increase. But according to Le Chatelier principle, the system will try to make the concentration of H plus constant. How it can make the concentration of H plus constant? The H plus ion will react with acetate ion to form undissociated acetic acid. If you add, say, as for example, if you add 50 H plus ions, then 50 H plus ion will react with 50 acetate ions to form 50 number of undissociated acetic acid. In this way, concentration of H plus remain the same, though you add 50 number of H plus ion from outside. Now, in this case, concentration of acetate decreases by 50, and this is salt, that is sodium acetate, is used. Sodium acetate is a strong electrolyte. It dissociates completely in aqueous solution. So lot of acetate ions are there. As a result, the number decreases of acetate ion in previous case is counterbalanced. That is, huge number of acetate ions are present. So if you add or decrease small amount of acetate ion, this doesn't matter. The concentration of acetate ion and H plus both remain almost constant. As a result, the pH of the solution is same. Now let us face a problem. Find the pH of 0.1 molar sodium acetate and 0.01 molar acetic acid solution. This is a buffer solution because it contains a weak acid and a salt, sodium acetate. So the pH is determined by Henderson equation. pH equal to pKa plus log of concentration of salt by concentration of acid. Now pKa value will be supplied in the question, and the value is 4.74. It is the dissociation constant of acetic acid, 1.8 into 10 to the power minus 5, and its negative logarithm is pKa. The value is 4.74. Concentration of salt is 0.1 and concentration of acid is 0.01. So pH is equal to 4.74 plus log 0.1 divided by 0.01. So it is 4.74 plus log of 10. We know that log 10 is 1. So the value is 5.74. So the pH of sodium acetate acetic acid buffer, which contains 0.1 molar sodium acetate and 0.01 molar acetic acid, is 5.74. Similarly, we can calculate different types of buffer solution. It may be basic buffer or it may be acidic buffer. Now, if one can question you that a solution contains 0.1 molar acetic acid and 0.01 molar sodium hydroxide. Is it represent a buffer solution? The answer is yes, it is a buffer solution. Why it is a buffer solution? Because 0.1 molar acetic acid will easily neutralize 0.01 molar sodium hydroxide and the remaining acid is 0.09 molar and 0.1 molar sodium acetate is formed. So the solution contains 0.09 molar acetic acid and 0.01 molar sodium acetate, which is a mixture of weak acid and its salt, so it is a buffer solution. Okay, thank you. That's all for buffer solution. For testing your understanding of this lesson and more videos log on to www.tubelessons.net.